Hello, everyone, again. Let's talk a little bit. Chapter 7 and 8 review. Chapter 7 and 8 review. Let's take a look at some of this. Might try to pause periodically and then have new blackboards up here. Might go more efficiently for people trying to look at this. Let's just remember how to do the things that we need to do. We'll set up the formulas. When you get the final answers, just make the round-offs as you need to do so, and as we've already discussed how to do so. So let's run through this. You know, we don't know to what detail we need to do this. If you need more detail on it, just come see me in person, and we'll take care of it, either in class or like otherwise. But make sure that you question what's going on if you need answers to whatever's going on regarding all this. For this right here, they'd like to find the angle B. Well, there's 180 degrees in a triangle. Here's 47 of those degrees. Here's 31 of those degrees. When you add them together, you've got 78 degrees. 78 degrees plus what number will give you 180 degrees total? There's 180 degrees in the triangle. Well, if I got 47 degrees and 31 degrees, it's 78 degrees. 102 degrees is what this has to be, because the 102, the 47, and the 31 would add up to 180. So you've got this. Find the area. The area is 1/2 base times height. It is half of the area of an associated parallelogram. That would be composed of two congruent triangles that look just like that. Its area would be base times height. Perpendicular height times the base. Well, if it's only this is half of a parallelogram, it's 1/2 base times height. It is 1/2. The base is 35 inches, and the height is 27. And they are saying, they're not really specifying to what degree of accuracy you're going, so just multiply them out and get what you're going to get. And what we have for this one is, just do all the multiplication, and you're indeed going to get 394.08. Meters squared. Now they're saying meters. I don't think they're supposed to be saying meters, but the mathematics is what it is. Let me see. No, they're not. I am looking at the wrong thing. It's on me. So that's not the answer here. Do the multiplication as is, and it's going to come out to 472.5. So they were not wrong. I was looking at the wrong. I was looking at the wrong answer. So it should be coming out to like this, guys. So here you go. There's the area. There is the other angle. Those are 1 and 2 for us. 3, the circumference is pi times the diameter, or 2 pi r. 2 times the radius of the diameter, then multiply by pi. Go either one. That is pi 3.1415926 times 22.4. In this particular instance, they're saying round to hundredths. When you grind out the process of doing it, you're going to get 70.37 meters. And this is in meters. Okay. Pi is about 3.1415926, and diameter is 22.4. You multiply them, you get this. You'll get a longer answer than this, but you'll round it to hundredths, and you'll get right here. So that's fine. That works. The area is pi r squared. What does that mean? You're not going pi times r, then squaring it. Nobody told you to do that. You're taking pi, then you're multiplying by r, you're multiplying by r. The r is squared. The r is the only thing that's squared. Then you multiply by pi. Well, pi is about 3.1415926. R is, the radius is half of this. Half of 22.4 is 11.2. Take this, square it, multiply it by pi. Again, pi goes, you use quite a good approximation for this. Let's see how far they actually went with it. And this is the 394.08. This is the 394.08. For the area. 394.08 meters squared. Sounds good. They're showing this. This small triangle and this big triangle are similar to one another. That means appropriate lengths are similar to one another as well. Corresponding lengths are appropriate to look at here. Corresponding lengths are similar to one another. So this small triangle is similar to this big triangle, and I've got quite a bit of film on this in an earlier film. We can look at that at another time, or hopefully have looked at it by now. Let's see what they're trying to tell us here. They want you to find EB, and I've highlighted it to make it maybe easier to kind of look at. And they're telling you what everybody else is. AE, this guy right here, is 18. ED is 12. DC is 36. So let's see what we can say here. Well, I'll tell you what. I mean, I think probably the best way to look at this, probably the easiest way to look at this, let's call EB, let's call the length EB, let's just call it X. Let's call short length of this particular similar triangle with this big similar triangle. They're similar to one another. Short length divided by long length, X over 36. And that corresponds to this short length and all of this, which is 18 plus 12, which is 30. Short length over long length, like this. And that's essentially, so what did we do here? We took this side, the 18 of the similar triangle, and the X of the similar triangle, and compared it to this long length right here, which is 30, and this long length, which is 36. So of the big triangle, 30 divided by 36, let me see exactly. In fact, that is, there's a number of ways I guess you could go with this. And they're all going to work. I mean, I'll show you both, I guess you could say. We basically looked at the really long length here of the real big triangle, and that's 30. And the really long length here, also of the same really big triangle, that's 36. This is 30, this is 36. Similar to that is what's going on with this triangle, which is similar to the big triangle. This small triangle is similar to the big triangle. This is 18, and this is X. 18 and X correspond to 30 and 36. So if that's the case, we also know that the X and the 36 correspond to each other, just like the 18 and the 30 correspond to each other. That'll work. Number of ways to go. You can do a reduction here. Let me not, in case there's more confusion than help. 30 times x is 30x. 36 times 18 is what this is. Divide by 30 on each side. Kind of interesting. Let me think what we could take out of here. We could take a 6 out of here and have a 5, and we could take a 6 out of here and have a 6. And what we have here is 6 times 18, which is 108, divided by 5. 5 goes into here 21 3/5 times. 21 3/5 is this. This will work. That is one way you could have done it. You could also said, well, look, why don't we compare 18 with 30? Small length, corresponding small length and corresponding long length. 18 divided by 30. Not the same as this, but it's going to be the same ratio. And, an x divided by 36. So let's see exactly how we, actually it is the same, the x over 30. Is there another way we could have done it? We could have. We could have said, within the actual ratio, we could have said, okay, this x over 18, this x over 18 corresponds to the 36 over 30. The crazy thing is, if you do cross multiplication, you're back to here. You're back to the same thing. You're solving the same thing. So number 5 should be 21.6, and it is. Let's go to 6. Area around to hundredths. Well, this is kind of an interesting dynamic here, you guys. If this is 6, if this thing right here is 6, it's not drawn to a good scale or anything, but if this is 6, and if this thing is 12, then this is another 6, right? 12 is the diameter of the half circle, so 6 is what's going on over here as well. 6, so 6 and 6 is 12. Add 5 to it, you got 17. So here's the 5. Well, what do we got here? Well, we said this was 12. This is 5. So we've got the area of the triangle, the area of the rectangle, and the area of the half circle. Altogether, they're going to add up to the area. Altogether, they're going to add up to the area. Well, let's see what we can do. We've got a lot here. I'm going to probably just try to buy us a little bit of room. Well, let's see what we can say. Well, the area of the triangle Another piece of chalk, you guys. Area of the triangle is 1/2 base times height. It's 1/2 the base. The base is this, the 12. The height is 5. The area of the rectangle, this thing is 6 across this way, and 12 in height that way. So 6 times 12, that's base times. And the area of the half circle is half the area of what the whole circle would be. Is half of pi r squared is half of pi r squared. The r is, the radius would be half of this 12. And that's where we're getting the 6 right here, you guys. And that's where the 6 is here. And that's it. I mean, we're looking at a situation it corresponds to this, to this, to this. Triangle, rectangle, half circle. You grind out the numbers, add them together, round to hundredths. Again, just watch it with pi. I'd probably take pi out pretty far out, not just 3.14. 3.1415926 is probably a better deal. And that would be this particular situation. So let's see what that is. Problem number 6. I don't know if I had written that in the past, but that is number 6. You're going to add them all together, you guys. And 158.55 rounded to the nearest hundredth. 158.55 inches squared. Here's your final answer on that one for number 6. Number 6, you guys. So rounded to the nearest hundredth. So that is 1 through 6 from chapter 7 and 8 review. 1 through 6. Let's do 7, 8, 9, 10, 11, 12, I guess. I mean, for some reason I don't see a 12 here. Oh, there it is. Okay, right. 7 through 12 if we can. They're saying for 7 and 8, find the volume and the surface area. Find the volume of the following figure. Find the volume of the following figure. And find the surface area of the following figure. And in both instances, round to the nearest hundredth. Well, let's get a few things straight before we do anything. This is a cylinder. It is 8.5 inches in height and 7 inches in diameter. Well, 7 inches in diameter means 3.5 inches in radius. And they want 7 and 8. They want the volume and they want the area. So this is the volume. This is the area. Let's figure it out. The volume of this is given by pi r squared h. Find, this is r, which is half of this. This is r. Pi r squared is the base area. move the base area through a height, and you have the volume. The base area is pi r squared, move it through a height h. And that's what that amounts to. Pi is about 3.1415926. R is half of 7, which is 3.5, square it, and h is 8.5. Grind those numbers, and let's see what they're trying to say. We grind those numbers, then we round it to the hundredths, as we're saying. That's 327.12 inches, 327.12 inches cubed. .12 inches cubed. Yeah, you round it. Again, that's rounded. You're going to likely. I mean, I'm not explicitly doing it right now, but you're doing what pi is. You're getting what r squared is. That's the only thing that's getting squared is the r. Here's pi. Here's r squared. Here's h. Grind it out. Probably a long answer more often than not. And then you take the long answer and take it, round it to the nearest hundredth. And you got that. Find the surface area. That's a good question. This one we might have to calculate it because we probably could get two different calculations on this. And I'm not entirely sure what they're asking on this. So let's watch out and let's do it. I get the impression he just wants to get, well, there's a number of ways you could do this. Let's be careful, and let's see what we can say. For 8, A would be, if you were to cut this cylinder right here, flatten it out, its circumference would be flattened out, and it would be the edge, the circumference would be the edge of a rectangle if you flatten it out. So bam, you cut this, you flatten it out, and it'd be 2 pi r. 2 pi r times h, you go 2 pi r times h, and that'd be the area. Well, yeah, but what if you want to find the areas on top of the soda can? The top and on the bottom. Well, then it would be this. It would be 2 pi r times h plus pi r squared on top and pi r squared on the bottom. That's pi r squared doubled. Could be one or the other. I mean, I guess the way they're going to answer it is going to kind of give us the hint. You could theoretically ask one way or the other. No specificity was given on this, so it's a bit ambiguous. These are both the right answer depending upon what you're being asked, I guess you could say. So let's see what the answer we're going to get, and let's see the answer that they're giving. So for this guy right here and here, let's just see. Well, here goes. We're talking about the top one. It would be, see here, let's just do it. 2 times, sometimes they have pi written right there, depending on the calculator. And I'm sure it's here somewhere, but for the life of me, I can't find it. And there it is. I can find it. 2 times pi. 2 times pi times 3.5 times 8.5 for the height. $186.9248. That's square inches. Well, okay. This one right here is going to be that same answer of that, but then you're going to add this to it. Plus, let's see what we got here. Times 3.5 times 3.5. Okay, let's see what this one does. I got 263.8938. Well, these are both valid answers. It just depends upon what you're being asked. Well, let's go backwards a little bit. 7 and 8. Seven, of course, we already got. It's 327.12. 8 is 263.89. You know what? It turns out it was the second one. It's good that we did not stop. This is if you don't count the tops and the bottoms. If you don't count the top and the bottom, this is the answer. If you do count the top and the bottom and the side, this is what you got. 263.89. Here we are. Uh, 263.89. We got it. Looks good. Find the side. Well, we're going to use the Pythagorean theorem for problem number 9. So let's take a look at it. We know that for any right triangle, the longest side is called the hypotenuse. It's opposite the 90-degree angle. There's always 180 degrees in any kind of triangle, no matter what. It's pretty interesting in its own right, I guess, right? And so let's see what we got here. We can say, let me see here, guys. You call this one A, you call this one B. There's a lot of flexibility, I guess what you call it. Call the longest one C. Usually that's the way it goes. And there's a lot of ways you can play this game. Well, if you're talking about this for number 9, let's play that game. Let's go over here. Let's call this 19.5 meters. Let's call this 15.4 meters. Let's call that a 90-degree angle. Let's call that A. Forgive me, guys. If you don't mind, I'm going to call this. Want it to kind of look consistent with this, I guess you could say. Trying to find what A is. Take this right here, subtract B squared on each side. Leave A squared by itself. Get A squared by itself, subtract B squared on each side. You got this. Don't take any shortcuts. There are usually no shortcuts when there's addition or subtraction going on. You can get square roots of products and quotients very easily if there's no addition or subtraction present. If it's only multiplication and or division going on, if it's only multiplication and or division going on, you can square things very easily, you can cube things very easily, you can square root things very easily. If it's only multiplication and or division going on, no addition or subtraction present. It's very easy to exponentiate, it's very easy to square root and get roots. Roots and exponents are usually pretty easy when there's no addition or subtraction present and it's only multiplication and or division. Please, that cannot be emphasized enough. Remember that. When it's something like this, you're not taking any shortcuts. You're squared on each side. You're getting the square root of each side, which isn't really going to help you. Well, it's going to help you, but an individual item is easy to square root. This you're not going to square root without grinding everything out. Without grinding everything out first. The square root of a squared is a, and this right here is c squared b squared. Sounds good to me. It's going to be, well, it's going to be that guy's C, that guy's B. You got 19.5. You can't just square root these individually and think it's C minus B. It doesn't work that way. You got to find what 19.5 is squared. You got to find out what 19.5 squared is, and you got to find what 15.4 squared is. And let's get it. I mean, from there you're going to find out what's going on to get the actual answer, you guys. So let me well, you know, there's a lot here. What are we going to say? Well, nineteen point five squared $380.25 and 15.4 squared $237.16. Yeah, you keep going. I mean, they're asking you to give an answer. Let's find out what it is. I mean, so we got 30.25 in there as well, right? Well, let me try that again, guys. 11.9620. Sounds good to me. What do they want here? I think they were saying for this one, 11.9620, round to the nearest tenth. Here's the tenth. Is it going to stay a 9 or go up 1? If it goes up 1, the 9 is going to be like a 1.0, which makes it to a 12. And that's what happened. And they communicate that by saying, yeah, this was rounded to the nearest tenth.
So that's 12.0, you guys, for that one, using that logic. 10, 11, 12. So let's see what they got here. We got a trapezoid for 10, and let's take a look at a few things, guys. All right, so we got things going on here of interest. Find the area. What is the area going to be equal to for the following item? Trapezoid. There's a good amount of asymmetry, and there is some symmetry as well. This is 36 meters in height. This is 35 meters across here, but it's 42 meters across here on the bottom. Find the area. Well, the area of a trapezoid is 1/2 the quantity base 1 plus base 2. In other words, take the average of the two bases, and move it through the height. Simple as that. So you got 1/2 of 35 and 42, whatever that's going to be. Then you move it through the height of 36, and that'll get you the area. So let's see what we got here, guys. There's a number of ways you can play the game, I guess. If you add these two, if you add these two, you get 77. That's 77. If you take half of 77, you can do that, or you can take half of 36. But you can't take half of both. You can take half of both in here and add them, and then that's it. You've done it. Or you take half of this. Or you can add these two. You can add these two and take half, but that's it. You can't go over here. Or you can take half of this one, then add those two, and then multiply. Well, let me see here. Let me just try to maybe do this in my head if I can. If this is half, you can't do both now, as we already said. Half of 36 is 18. Add these two together, you get 77. 77 times 18. I might well try to do this in my head. 77 times 18. If it was 77 times 20, it would be 1,540. But it's going to be 154 less than 1,540. So 1,540 minus 150. 1,540 minus 150 is minus 154 rather. I'm sorry. So 1,540 would get down to 1,400. It'd be 1,386. And that's kind of a guess. So I'm not sure I should be making that kind of a guess, but here we go. So anyway, we can do it on the calculator and find it if we need to. But let's see where indeed that is. That is number 10.
Yeah, 1,300, there it is. I lucked out with that one. 1,386 meters cubed, squared rather. 1,386 meters squared. 1,386 square meters. Sounds good to me. Whenever you're talking about volume, you're talking about cubic units. Think of volume as three-dimensional, and the 3 to remind you of 3 dimensions. You are cubing not the number, you are cubing, you're cubing not the number generally, you're cubing the unit. So it's cubic units, cubic meters for volume. Square units, two-dimensional, you're squaring the unit. Length and perimeter and circumference, just regular linear units. Meters. So length, perimeter, circumference, just meters. Square units for area and cubic units for volume. Okay, so here you go for the area. That was 10. They're asking something of interest here. You got to be careful. Don't get careless. They are asking you to take 1,228 square inches to square feet. Now let's talk. This is pretty important. 1 foot is 12 inches. 1 foot squared, not 12. 1 foot, the quantity 1 foot squared is not 12 inches. It is by 1 foot, which is 12 inches by 12 inches, which is 144 square inches. This is important. 1 square foot is 144 square inches. Very important. It's not just 12 square inches. This is the initial thing that makes it happen. Let's keep talking. If you were to take 1 cubic foot, 1 foot cubed, that's not 12 inches cubed, just like it wasn't 12 square inches. It was 12 by 12, it was 144 square inches. This is 1 foot by 1 foot by 1 foot. Yeah, that's certainly not 12 cubic inches. It's 12 inches by 12 inches by 12 inches. 12 times 12. 12 times 12 is 144. Times 12, it's going to be 1,440 plus 288, which is 1,728. And that's cubic inches. Make sure it's right. First of all, I'm writing this down. Just for the record, we got it. Let's just try to look at it again. 12 times 12 is 144. Times 12 is 1,440 plus 288. 1,600, 1,700, 1,728. I'm going to stick with that. Just so I don't lead you astray, I'm going to actually check it on the calculator as well. But the one that we care about right now is this one, but they're all pretty good. They're all, useful to visualize a number of things, you guys. Let's have a look. $1,728. We're good. We're good. All right, this is the one we're going to use. There are conversion factors all over the place. Let's use them.
Let's use this one. Because it's like this, what did we say last time? You can put one of them on top of the other. Which one? Doesn't matter. It depends what you're being asked. If you want square inches for the answer at the end, you take the one that has square inches on top. If you want square feet on top, if you want square feet as an answer at the end, you put this on top. If you want square inches, if you want square feet at the top, you put square feet at the top. If you want square feet as the answer at the end, you put square inches on the top if you want square inches at the end for an answer. Well, I want square feet. I'm going to use that one. I'm going to take the 1228. I'm going to take the 1228 inches squared. I'm going to multiply it by this. 1 foot squared corresponds to this. And that'll get you there. I'm looking at this thing all over the place. I'm trying to think if there's an easy way to pull something out of here and make it happen. 4 goes into here 36 times. 4 times 36, right? Yeah, 4 times 36 is 144. 4 goes into here. It's a good question. 4 goes into here 307 times. So 307 and divided by 36. Trying to think, is there a 9 that goes in there? There's got to be a way this stuff cancels out. Right now, let's kind of cut to the chase. But I'll take the 1228 and divide it by 144. .52777. Keeps going. 8.5278, I'll say. 8.5278 square feet. Yeah, it's going to be a smaller answer. Why is it going to be a smaller numerical answer? It's the exact same answer. It's the exact same size. It's the exact same amount of quantity. Certainly it's the exact same amount of quantity. Why is this number, 8.52, smaller than 1228? Because a square foot is a very big unit. You don't need as many of them to describe the same reality as square inches describe. It's a very big thing. It's a very, very, very important point. So when you look at it, so we got 11 here. They're asking us to what degree to take this. 11 round to hundredths. Is that 2 going to stay at 2 or is it going to go up to a 3? It's going to go up to a 3. And there it is. .53, let's make sure that we're all speaking the same language here. 8.53 square feet. Sounds good to me. All right, let's go to 12. 12, a rectangular, again guys, any kind of conversions you want to do, it can have this over that, or that over this. It can have this over that, or that over this. Same thing here, this over that, or that over this. Doesn't matter, you can always have them looking something like this, just like with the cubic feet. You got this, you got the 1728, cubic inches, or you got the 1728 cubic inches, and you got et cetera, et cetera. Sure, either way it's going to work. Why do they work? Because 1 square foot is 144 square inches. Doesn't matter which way you write it. 1 cubic foot is 1728 cubic inches. So they're both one. It's a weird one.
It's like saying $100 bill is the same as 100 singles. Well, 1 and 100 aren't the same. How is that fraction equal to 1? Well, the 100 singles, each one is 100 times smaller than that $100 bill. These are very small. They're 144 times smaller than one of these. But they're the same amount, each one, so the ratio is 1. It's a very important, very subtle reality that we want to be in contact with when we're doing the mathematics. They're talking about number 12. Let's say a couple things about it. Number 12. Number 12. A rectangular steel plate is 55 inches wide. A rectangular steel plate is 55 inches wide, 27 inches long, and 0.5 inches thick. So now we're talking about something that's a volume. It's a box. The density of steel is 0.283 pounds per cubic inch. Find the weight of the plate round to hundredths. There's a lot here. The Greek letter rho means density, mass divided by volume. Other places are going to use weight density. Here they're using weight. They're not using mass. They're not using kilograms per cubic meter. But the basic argument is, so just kind of be aware of that. The basic argument here, guys, is, let's see here. You've got weight per volume of steel, of this steel. The density of steel is 0.283 pounds. 0.283 pounds per cubic inch. That's the weight density of steel. To find its weight, it's kind of interesting. I mean, you could kind of say density. Get a little awkward here. I'll use the word D for density, for weight density. So if I want to find W, I'll multiply by V on each side. I go the density times V. If I multiply by V on each side, I'll get W. Well, I'll take this 0.283 pounds per cubic inch, and I'll multiply it by the volume. And that will give me the weight. Well, how does that work? Well, how about 0.283 pounds the volume is 5527.5. Remember, the volume of a box is length times width times height. The wideness is 55. Doesn't matter what order you write these. It's 55 wide, 27 long, and 0.5 thick, or it's got a height of 0.5. And that's where this comes from. This is going to be cubic inches, guys, at the end of the day when we do this. So you actually multiply them out, and we'll get what the weight is. And they want you to, what are they saying here? Round it to hundredths. So
you got to do is multiply it out. 0.283. What do we got here? We got 0.283 times 27 times 55 times 0.5. 210.1275. It said round it to the nearest hundredth. These are pounds. This is going to be cubic inches, and they're going to cancel. Cubic inches here is going to cancel with cubic inches. When all three of these are put together, you got cubic inches. The cubic inches and cubic inches are going to cancel, and you got a weight of 210. Here's the 7 right next to the 2. It's going to bring it to a 3. And there's your answer, 210.13. Let's see what that was number 12, I think, right? Okay. Number 12. 210.13. Absolutely. Absolutely. Let's keep going here, guys. 13. Thirteen is saying find the missing angle or find the unknown angle. I mean, they're doing this. They're doing that. I don't know what x is. It's just a guide. You can't really measure those. You got to go with what they give you. That's 110. This is 30. All of it's got to be 180. 30 plus 110 plus x is going to be 180. Add these, you got 140. What number added to 140? What number added to 140 gives you 180? You know x is going to be equal to 40. Subtract 1, x is going to be equal to 40. 40 plus 140 is 180. Subtract 140 on each side. So there it is. Let's go to 14. Okay, that's up to there. Let's proceed like this. If I need to take a pause on the film to kind of set some stuff up, it might be more efficient for you guys when you see it again. You're not having to see all the downtime. We'll see how out. We'll see when and if I need to do something like that. So they're saying a number of things here. They're saying for 14. How does this play out? Well, every time you hit 60, you're going to something else. 60 seconds in a minute, 60 minutes in a degree. So if you add these up, when you hit 60, you put down, end up going over here, you add a minute to it. You add these two right here, and you got 76. 76, let me take 60 away from 76 and leave 16 seconds. The 60 seconds I'll take over there, I'll call it a minute. Now put a minute, 2 minutes, and 8 minutes. That's 11 minutes. That's, so that's this, and this is 11. This, and this is 9. 91 minutes. Well, I tell you what, let me take 60 away from here. 60 away from 91 is 31 minutes, and that's 1 degree. 1 degree, this, that's 3. This is 70, and there it is. One degree is 60 minutes. 1 minute is 60 seconds. So you got to keep making those conversions. Every time you hit 60, you call it 1 of something, and you put the 1 over here. And add them together and go for it. So 73 degrees, 31 minutes, 16 seconds. Let's have a look. 14, correct. 73 degrees, 31 minutes, 16 seconds for 14. So 73 degrees, 31 minutes, 16 seconds. Sounds good. We got it. 15 and 16. It's a hard one to kind of plot on a board here. They want you to plot three-dimensional space, x, y, z, 1, 3, 5. So let's see what we got here. So this is z. This is x. And this is y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, not a good drawing here, guys, but basically, this is the x-axis. This is the y-axis, and this is the z-axis. And can you graph 1, 3, 5? It's of the form x, y, z. It's an ordered triple. It's 1, 3, 5. Here's 1. Here's 3. And it comes up to here. Here's 5. This is a lousy drawing, guys. I'm not drawing it too well, but this is, like I said, this is 1 over, this is 3 over, and this is 5 up, and try to somewhere at the corner of that box that's formed, see what's going on, see what's happening there. So that's how that's looking. 16 is kind of playing the same game. The way that thing's located in your in the question sheet that's going to scroll at the back of this page, it's, 3 in the x direction, 5 in the y direction, and I don't know, it almost looks like 1, 2, 3, 4. Okay. That just doesn't look right. Okay, that's 4, I guess, yeah. So it went, the way it looks for 16, you guys. And again, I think you're better off looking at what's actually being presented, either in the hard copy that you have or what's scrolling at the end of the video. The x is 3 in the positive direction. The y is 5 in the positive direction. And upward, they gave us that little ladder, and they got it up to 4. So it's looking something like this. for those. A little more difficult to draw it on a board. It's easier to look at it, I think, when you. So what do we say here? For 16, here we go. For 16, it's 3, 5, 4. For 15, you know, the 1, 3, 5. Yeah, they drew it a whole lot better than I did, that's for sure. So look at it. The answer should be there on the, we're going to have that scrolling on the film, so you'll be able to see it. All right, that gets us through 16. Let's keep going. Let's finish strong here. So a number of things going on here. Let's see how we're going to play it. See what I can do with that. Let me write them, and we'll kind of take it. Divide or multiply, reduce to lowest terms. What lowest terms are is sometimes arguable. I mean, sometimes you can write things in different manners and still have them theoretically, or at least theoretically in the eyes of many, be lowest terms. There's certain things that are just not lowest terms for sure. So let's see. See what we can write, guys, and try to make some sense out of this. Let me see here. So let's see. We got a number of things. We remember the rules, guys. Let's see what can be done and cannot be done, okay? It's pretty important in that regard. For 17, they're saying 5xy, 20z, 4z squared, 15x squared y. 4 cancels into 20 5 times. Z cancels into z squared, z times. 5 cancels into 5 one time. Y cancels into y one time. X cancels into x squared x times. Let's see if more things come up here, guys. I think we're done, but let's just be sure. The top, multiply across what you have. 1 times 1 times 1 times 1 times z is just z. 1 times 1 times 15 times x times 1. It looks like that's it. Now let's make sure we didn't miss anything. We can always double check it. So what kind of answers are given here on this? 17, right? Right, I'm gonna stay with that. I believe that to be true. 17 is, I don't know where that came from. I don't know where they're getting, I do not know where they're getting z squared. I swear I don't know where they're getting z squared. I must be missing something again. Let's take a look. Oh, they're getting it because I didn't see it. This z is z to the third. So when z to the 1 goes into z to the third, you got z squared. Absolutely. Absolutely. It was z to the third. For some reason, I read that to be z squared. My fault. Absolutely. It was z cubed. Z cubed divided by z is z squared. Everything else was right, and in the end, that's the right answer. 18. They're saying a lot. Don't put yourself in a bad spot. Make sure that whatever you're using works. You might think you can do some things, but you can't. And other things you definitely can. This R plus S, I can kind of go parentheses within parentheses. Here's another R plus S. Whatever this is, it's the exact same thing as that. These don't go. If there was a 3 here, you could pull a 3 out of there, and you'd have an XY to cancel. But you don't have that here. This doesn't go any further. You got 3x minus y. You put it in parentheses if you want. 1 times x minus y, and that's it. That's done. You can leave it in parentheses, or you can, you know, if it's the end of the day on that, you can leave it like this too. It is implied that they're in parentheses. It is implied. So either one of those is fine. That was 18. Three x minus y, the quantity 3x minus y on top and x minus y on the bottom. The quantity 3x minus y over the quantity 3x minus y over the quantity x minus y. Sounds good to me. That's 18. See what else we can say here, guys. 19 is h plus 2 over 3. Divided by h plus 2 over 3, h plus 2 over 2. Sounds good. A fraction divided by another fraction is the first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. You can take h plus 2 and put it in parentheses and put the 3 on the bottom. You could take the h plus 2 on the bottom here and put that in parentheses. You got 2 right here. These are identical. A fraction divided by another fraction is the first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. Write it like this. Just always check, guys. Always check. I mean, that was 19. 19 is 2/3. 20. There's a number of ways you can write. 20 you can maybe write it 2 different ways. That's the idea of reduced to lowest terms kind of thing. Reduced to lowest terms. You got f over t over 1 minus a. Kind of an interesting situation. This f over t on top, you can just write it f over t times 1 over 1 minus a. That can be written as f times 1 is f. If there's a t on the bottom here, you can bring it right here to this bottom. I don't know that there's a problem writing it like this. The answer key doesn't have it like this. They have it very close to this. This is probably fine in many circumstances. The way the answer key has it, you go to here and you take the t, distribute the t on the bottom there. It's probably a better way to write it like this. Frequently you see either one I've seen it accepted in various basic mathematics classes, or at least in one of them, I've seen something like this accepted. One or the other should be fine. We'll talk, you know what I mean? But this is maybe a little more rigorous. I don't know. You could argue this too. So the way they have it, so for 20, yeah, it's F over the quantity T minus TA. And that's that one way over there on the far right. But that's likely acceptable. 21. They've got some interesting looks here. 21, 22. Let's see how the whole thing's going to play out. Let's see. Let's talk about it. 21. There's a number of ways to go with some of these. Once you got the technique, it's not too bad. Just be careful. Here you got A over 2 minus B over 2. Tell you what I'm going to do. A number of ways to go here, but I think one way to go is get common denominators. We already got one right here. I got a 2 on the bottom right here. If you got a common denominator, leave it alone and add or subtract the bottoms. Okay, well that's how the bottom looks. Pretty good. 1 is the same as A over A. A over A is equal to 1 minus B over A. You got a common denominator, leave it alone, subtract the tops. Subtract the tops and keep the common denominator. A fraction divided by another fraction is the first fraction, the one that's being divided. A fraction divided by another fraction is the first fraction that's being divided, left alone, multiplied by the reciprocal of the second fraction doing the dividing. You guys understand where I'm going? I just put something there I didn't want to put there just yet, but I'm going to soon. We're here. What's going on here? The quantity A minus B on top is a self-sufficient quantity. So is the A minus B on the bottom, and they're both identical. A minus B equals A minus B. A minus B, whatever the heck it is the same as A minus B, whatever the heck it is. 1 times 2 is 2. A times 1 is A. For 21, you got that. Let's always check this, guys. I'm always a little apprehensive. Yeah, that's 2 over A. That's 2 over A for a final answer for 21. 22. You got V over R, and you got 1 minus V over R. How's that going to play out? You're going to basically play the same game we've been playing. Just be careful with it. V over R is this. 1 is the same as R over R. Is r divided by r equal to 1? Why did I do that? I want a common denominator. There's the r. I got v over r. Then I got, if I subtract these, I have a common denominator, r, and I got r minus v, whatever that's going to be. Whatever that's going to be. A fraction divided by another fraction is the first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. You know where I'm going. I probably didn't even have to take the above step here. I could have gone right to here. Like this. The r minus v, right, behaves like this. As a quantity, r minus v, there's an r. The r cancel. Multiply across. One times v is v. 1 times r minus v. You don't have to put the bottom in parentheses. I would, but I would. I mean, it just kind of, I think it's just more mathematically, it communicates the mathematics really well, that's indeed a quantity. You can argue either way. It should be pretty obvious either way, but I tend to do that, kind of in a meticulous sense. That's number 22. 22 is saying v over the quantity, r minus v. They don't put parentheses. I do. That's not going to be a problem. One or the other's fine. One or the other's fine. That was 22. Let's keep going with this. Like I said, I was almost going to stop the film, pause it, and then pick up later. It might go a little bit faster. I don't know. We're going at a decent pace. You can always speed this up as well. Let me see what I can do. Let's get through this. All right, guys, let's see what we got. See what we can say here, guys. How some of this stuff simplifies. We got 23, and it plays like this. You got AB over 2 minus 5AB, also over 2. We need a common denominator. You got one. It's called 2 on the bottom. AB is the same as 1 times AB. What's 1 apple banana minus 5 apple bananas? 1 apple banana minus 5 apple bananas is negative 4 apple bananas. You got negative 4AB over 2. Now we're about to be done. 2 goes into here negative 2 times. Negative 2AB for 23. Let me do 24. Then we'll look at both. (24) is saying 2 over g minus 1 over 3g. Well, I'm close to getting a common denominator. Tell you what I'm going to do. I'm going to take the 2 over g, this minus, I'm not going to go for it yet. I got 3g here on the bottom. How do you get 3g right here? Multiply by 3. Yeah, I know, but I don't want to change it, so I'll use a special one called 3 over 3. 3 times 2, 3 times 2 is 6. 3 times g is 3g. This is 3g here. You worked hard for the common denominator. You have it. 6 minus 1 is 5. That one's done. That one's done. That's 23 and 24. 23 and 24 is negative 2ab and 5 over 3g, respectively. Negative 2ab and 5 over 3g. Yeah, we're looking good, guys. 25, k over r minus p over v. A little more complicated. K over r minus p over v. What's r times v? It's rv. I got to get the rv. I got to get a common denominator. Here's an r, here's a v. Man, they got nothing in common. I'll go r times v to get rv. Rv is what I'm shooting for. By what would you multiply r to get rv? How about a special one called v over v? By what would you multiply v to get rv? How about a special one called r over r? V times r, forgive me, v times k is kv, v times r is rv. P times r, or r times p, is rp. V times r is the same as rv. Is that true? Sure, if you cancel the v's out, you got k over r. That's what we had initially. If you cancel the r's out, you got p over v. That's what we had initially. But now we worked hard, we got the common denominator, and that's going to be rv. Subtract the tops. RV is the common denominator. It's kv minus PR or RP. It's not a big deal. Let's make sure we get it. That is 25. And they say P, they call it RP. They call it PR. I call it RP. That doesn't matter. KV minus PR or RP, KV minus RP, that difference, the entire difference, KV minus RP, that entire difference over RV. That sounds good to me. 26. That's an interesting problem. It's not too bad. Comes out pretty good for us, actually. But let's look at it. For 26, they got h plus 1 over c minus w. And they got h over c minus w again. Well, that's good. We already got a common denominator. I'll tell you what. I am going to put parentheses around here before I do any kind of subtraction. I'm going to do that. I'm going to do that. I am going to subtract. I'm going to go h plus 1 minus h. That's just 1. The common denominator is already there. You can leave it in parentheses or just leave it like this. It's understood to be the same thing. Either one is fine. So we got it. Just make sure, in case I didn't miss something here, guys. It's easy to miss this stuff. You got to look at it carefully. 26 is 1 over the quantity c minus w. 26 is 1 over the quantity c minus w. On the bottom. It's fine. Looks very good. 27. And you can argue this a whole bunch of ways, I guess. You almost could just leave it, to be honest with you, for 27, but let's take a look at it. M over t plus w. trying to follow some of their logic. I get there is some way, I guess you could say, potentially, but like I said, let's kind of follow the way they've been going with us on this. Trying to find their logic, guys, to be honest with you. Okay, they want to play it like that. They want to make it one. They want to make it one fraction. They want to make it one fraction. Well, let's do it. W, if you multiply it by t over t is 1. W is the same as w divided by 1. W divided by 1 is the same as w. T over t is just 1, multiplied across. You got m times t, m over t rather. You got wt here. 1 times t is this. You got a common denominator. Heck, leave it alone. Let's just see what they wrote here. They're going to write TW, or this is not an issue, so I shouldn't make it one. They didn't write WT, they wrote TW. That doesn't matter, as I said before, guys, but that's fine. This will work. All right, my friends, that's 27. Let's pound through. Let's get this thing done. Didn't have to pause it this time. Other times you can see that might get paused. But let's take a look at it. All right, guys, I'm running out of battery time here. Hopefully we got it straight. Let me run through it. Should be okay. Okay. I'm just testing the volume, guys. Let me see here. And the battery. It's going well. Okay. I can still keep going. So let's see what we got here, guys. Let's take it. Let me go pretty fast, I guess. 28 is 2v over pw minus, I'd like to box it off because I'm not touching it yet, over w squared. Well, I got a w squared here. I only got one w here. I got a p here, and I don't have a p at all. Tell you what I'm going to do. I'm going to take, for this whole process, I'm going to get a w squared here by doing a special one, w over w. And I'll get a w squared here, and I got a p. I don't have a p here, though. I'll go special 1, p over p. So I think at the end of the day, w times p times w, w times p times w is pw squared. And so w times p times w, w times w is wp squared. W squared times p is pw squared also. Good, that was the goal. W times this is 2wv. B times p is bp. Two WV Yeah, looks pretty good. Again, you're doing special ones to get the common denominator if they're going to ask you a question like that. That was 28. It's 2WV minus BP. 2WV minus BP over PW squared. They got 2VW. I got 2WV. They got 2VW. I got 2WV. That absolutely does not matter. That's 28. 29, 30, 31. Let's see what we got. It's functioning still. Okay, the sound's still working. Okay, the battery, I'm not going to change the battery just yet, guys. I'm just trying to go for it, I guess. 29. 29, break up the fraction into two fractions and reduce to lowest terms. Okay, they're saying 3z squared minus 15xz divided by 3zx. Take this guy. If there's a minus or a plus, you do have to distribute. If that was a straight out multiplication, you'd only hit the division once. You'd hit the division here or here, but not in both places. If it was a multiplication, you can only hit the multiplication or division once. If it's multiplication and or division only, with no addition or subtraction, there's no addition or subtraction present. There's no addition or subtraction present, and there's multiplication and or division, you're only hitting the multiplication or division in one place, and that's it. If there's addition or subtraction present, you will distribute across the addition or subtraction. You're going to distribute across the addition or subtraction. 3z squared over 3z x. 5xz over 3zx, or 3zx, why not? What do you got? Well, the 3's cancel. Z cancels into here, just z times. There's your x. Z cancels. X cancels. 1 times z. 1 times z is z. 1 times 1 times x is x. So it's z over x. Now I'll put the subtraction in there. I'm not really going to do much with it. There's not much I can do, I think. But let's see what we got here. 5 times 1 times 1 is 5. 3 times 1 times 1 is 3. It's about all it goes. Now, if they showed you something like this and they said, make this into one fraction, you want to believe you come right back to here? It's kind of interesting. It comes at the end of the song and dance, you can bring this right back to here. There's probably other ways you can actually do it so it's not, it probably wouldn't be as convoluted as this because you wouldn't have to worry about, you wouldn't have a z in here. The x would stay because you got an x here. You can't do much. Here you can cancel an x, but there's no x over here. But there's z here, z here. This would be z to the 1, and this z wouldn't be here, and the z here wouldn't be here. So if you made it, it'd be 3x on the bottom. On top, it'd be 3z minus 5x. And that's where that came from if they asked you to go there. They're not asking you to go there. They're asking you to break it up and make it go to here. So what do we have here, guys? We've got, right, so that was number 29. 29, okay, am I missing something here? Was that a 15? Could have sworn that was a 15. Let me see here. They might have made a mistake on this one. Then again, I've made enough mistakes, I tend to doubt it. They probably did it right. There is no way they are right on this one, actually. There's 3z. Let me see here, guys. There's 3z squared, 15 xz and a 3 here and a zx, and let me see here. The 3's cancel, the z cancels, the 3's cancel, you got a z on top, you got z over x. Okay, I buy that. Here, the x's cancel, the z's cancel. That's a 15. That's a 5. Yeah, they're right again, and I'm wrong. The z, yeah, that is it. They have a 3. There's a 15 and a 3. That's 5. 5 times 1 times 1 is 5. 1 times 1 times 1 is 1. They are right again. They're batting 1,000. I'm sure not. You got to watch. It's easy to make it. Easy to make that mistake. That's 5 over 1 or just 5. There it is. At least we catch it. That's 29. So what do we say that was? That was z over x minus 5. For which one? 29? Yeah. Z over x minus 5. Z over x minus 5. Let's go 30, 31, and let's see what we're going to do here. For 30, they've got 6t 3w over 3p plus 9v. Pull a 3 out of here. Pull a 3 out of here. It is 2t plus w over p plus 3v. You don't have the parentheses there. You don't have to have the parentheses there. I typically do almost always, but that's not really necessary. It's fine if they're there, and this is the answer in the end that you're getting. So with this one, for number 30, 30 you got 2t plus w over p plus 3v. Right. Right. 2t plus w over p, 2t plus w over p plus 3v. Sounds good to me. All right, guys. 31. They want you to reduce it, and we're done with this particular worksheet. So 31, see what's going on here. Okay, it's still functional, so it's working here, guys, as we're doing this. It's not a really hard move to make. You got f right here. You got af plus f right here. That's the same as f right here on top. Pull an f from the bottom. Pull one of these f's from the bottom here, guys, and it becomes a plus 1. F and f cancel. There's a 1 there. Don't forget, there is a 1 there on top. And on the bottom, it's a plus 1, or 1 plus a. Parentheses or no parentheses, that's not a big deal, as we said. Get the right answer, and this is definitely the right answer, guys. It's 1 over a plus 1. 1 over the quantity a plus 1, and they don't have parentheses on there, but that's fine. 1 over the quantity a plus 1. Okay, very good. We'll talk again soon. Take care.